On October 20th, 2025, the internet broke for millions of people. There was no warning, no dramatic countdown. It all started quietly, with a few apps acting strange, a couple of services timing out, and then almost instantly, things began to fall apart. News stations started reporting technical issues, timelines filled with people asking if anyone else was having trouble. Hospital systems froze, airline check-ins stopped working, payments crawled to a halt, people were locked out of their banking apps. For a few hours, the modern world felt unusually fragile, and it wasn't a cyber attack. There was no power grid failure, and everything pointed to one place: a quiet patch of forest in northern Virginia. Nothing remarkable at first glance, just trees and fences, but behind them sits one of the most important parts of the modern internet, a region called
US East 1.
First, though, at 5:30, we begin with breaking news this half hour. We're following many websites and services are offline this morning following a major outage.
Yeah, the issue stems with Amazon Web Services, or AWS.
This major outage of Amazon Web Services causing a number of high-profile websites to go dark this morning.
Internet outages reported issues with dozens of major sites. This includes Amazon, Venmo, Hulu, McDonald's, and Coinbase.
Now, this outage first hit early this morning, knocking dozens of companies offline, from government websites to crypto platforms and AI tools.
Seeing kiosks at LaGuardia Airport.
AWS powers roughly a third of the cloud market, and the issue stemmed from a failure in its Northern Virginia data center. It does highlight how fragile the internet's backbone has become, that there are significant API errors and connectivity issues across multiple servers in its US East 1 region.
To understand how a single region could break the internet, we have to zoom out, way out. Long before Amazon was the world's largest cloud provider, it was just an online bookstore with a scaling problem. Every holiday season, their servers would buckle under the load, and their engineers kept building internal tools to solve it. Tools for storage, tools for computing, tools for scaling massive amounts of traffic. By 2006, Amazon had a realization. Those internal tools were far more valuable than the store itself. If they could turn their infrastructure into a product, if anybody could rent Amazon's computing power, they could change the entire tech industry. That idea became Amazon Web Services, or AWS as we know it. And the very first region they built was in Northern Virginia, the place that we now call US East 1. At first, it wasn't chosen because it was special. It was chosen because Amazon already had data centers there. Cheap land, huge fiber routes, and proximity to Washington, D.C. But as AWS grew, something unexpected happened. Developers kept choosing US East 1 as their default region. And as millions of companies migrated to the cloud, US East quietly became the backbone of the modern internet infrastructure. To the outside world, a region sounds simple, but inside AWS, a region is an enormous cluster of data centers, football field-sized buildings packed with servers, storage arrays, and networking gear. Each region is split into separate availability zones. These are isolated buildings designed so that if one fails, the other ones will stay online. That's the theory, but in practice, US East 1 became something different. More apps ran here, more APIs depended on it, more authentication servers, more storage buckets, and more internal tools. At a certain point, US East 1 stopped being just another region. It became the default region for the cloud. It became the region that everything else quietly depended on. A single point of failure built into the heart of the internet. And over the last decade, it has failed badly, and multiple times. In February 2017, a routine maintenance task inside of US East 1 triggered one of the worst outages in cloud history. The failure came from Amazon S3, the storage service that quietly holds a huge chunk of the modern internet. Most people don't realize how big S3 is. It stores trillions of files, photos, videos, website assets, app data, backups, and just everything. It is built to be incredibly durable, and if an entire data center vanished, your files would still be the same. But beneath all of that durability, S3 relies on something far more fragile, a massive metadata index that keeps track of where every object is physically located. You can think of it like a giant library. The books are safe, but if the card catalog and the author names and titles disappear, how are you going to find any of the books? And during a maintenance task, an AWS engineer ran a standard command to restart a small set of index servers, a command that was used thousands of times before, but this time one parameter was wrong. Instead of restarting a tiny subset, the command mistakenly removed far more servers from the cluster, including the machines that manage S3's entire indexing layer. In the moment those servers went offline, S3 didn't lose data. It lost the ability to find the data. Every request, from fetching a profile picture to loading a JavaScript file, suddenly returned nothing. And because so many companies rely on S3 for basic web content, the outage was disastrous. Websites wouldn't load, login pages broke, apps froze waiting for assets, and entire businesses went offline. A single mistyped command brought half the internet to a halt. And the most unsettling part? Amazon later revealed that no one expected this failure mode to be possible. The index was never supposed to go down. But in US East 1, anything is possible. In November 2020, US East 1 experienced a kind of failure no one expected. AWS lost visibility into its own systems. It started with a software update to Kinesis, a real-time data streaming service that moves data inside of AWS. Most people never interact with it directly, but inside AWS, Kinesis is everywhere. Kinesis is the system that keeps AWS aware of itself. It sends streams of information into CloudWatch, which is AWS's monitoring dashboard that tracks performance, health, and errors. Login pipelines, the systems that record what services are doing. Health checks, and these are tiny tests services run constantly to confirm they're working. Together, these tools form the nervous system of the cloud. But the update introduced a subtle memory handling bug. At a small scale, it went unnoticed. But in US East 1, the busiest region, this became a huge issue. As traffic ramped up, Kinesis nodes began hitting memory limits. Once a node couldn't allocate memory, it stalled. When enough nodes stalled, the entire Kinesis shards backed up. Latency started to skyrocket. Then AWS hit the real problem. Because so many internal systems depend on Kinesis, when it slowed down, monitoring itself began to fail. CloudWatch alarms didn't trigger, dashboards stopped updating, and health checks stopped reporting. AWS wasn't just experiencing an outage. It was experiencing an outage without telemetry, or we can also say they were flying blind inside of their own cloud. Users began to feel the impact immediately. Authentication outages, IoT devices failing, and according to my mom, which is the worst part, Alexa went down. The post-incident analysis revealed something deeper. It had quietly become a critical internal dependency, and when a system like that slows down, it prevents you from seeing what's broken. If a single internal service handles too much responsibility, its failure can blind an entire cloud region. In the early hours of October 20th, 2025, something broke inside the world's largest cloud, and the world felt it immediately. At first, the cause was not clear, but inside US East 1, engineers were staring at another problem that was not supposed to happen. Behind the scenes, AWS uses an internal DNS automation system to manage endpoint records. These aren't public DNS records regular websites use. They're private records, the ones AWS services use to talk to each other. Every major AWS service such as DynamoDB and Lambda rely on these internal DNS entries to route traffic correctly. But on that night, two automation processes attempted to update the same DNS record at the same time. One process finished successfully. The second saw the record was in use and rolled back its changes. And during that rollback, it deleted the DNS entry entirely. In a single instant, the routing layer for DynamoDB inside of US East 1 vanished. Without that DNS record, services could not resolve internal AWS endpoints. Anything relying on DynamoDB's control plane started returning failures. From the outside, it looked like a global failure. Banking apps weren't loading, and entire websites returned connection errors. Inside AWS, teams scrambled to rebuild the missing DNS entry and stabilize the routing layer. But because retries were still flooding the region, restoring the service took hours. The official postmortem described the root cause as a race condition, and in this case, this was two internal systems updating the same DNS entry at the same time. A tiny bug in a massive automation workflow. A single DNS record deleted, leading to a whole region going down and millions of people affected. And when everything was fixed, it became clear. Even today, after decades of cloud evolution, US East 1 is still a single point of failure for the modern internet. And if a mistake this small could break so much, maybe nothing has changed at all.